Well, hi, good morning, and thank you so much for joining me in my shop. Today is October 2nd, 2024, and I'm about to start work on this nice looking radio. A little dusty and dirty, but interesting looking radio. Lots of knobs and stuff to turn. If this is the first video of mine that you've watched, let me just say a couple things. One is I pretty much turn on the camera and go to work, and whatever happens, happens. And that includes good stuff, but also bad stuff, stupid stuff, things like that happen in here. So this is not an edited video in particular, and certainly not scripted in any way. So just so you're aware. And it really is me. This is not AI. It really is a human being doing this. Yeah. So, okay. So today, what I really want to do is just look this guy over and maybe get him plugged in and turned on and see what happens. We'll see how that goes. So, first thing is to take a good look at the outside of it. You know, this is great. It really is, because it has all of its knobs. This button's depressed right now. Okay, so this one's not popping out. So these do not seem to be doing anything. So normally you push these in, and it'll actually rotate the capacitor, some of them, rotate the capacitor in the back, and you'll see the pointer shoot across. The fact that this is stuck in is probably part of the picture. So unfortunately we've already found something that is... Oh, I just push harder. Push harder. Well, I don't know what's going on. I don't want to push too hard on it. Pointer's moving a little wee bit. It's stuck in there again. Okay, probably lubrication. It could be as simple as that. Well, let's try moving the pointer with the tuning. Yeah, pointer moves no problem. Sometimes these buttons are actually turning on and off different sets of coils in the back, as opposed to working mechanically on the tuning. But I think this one is a mechanical one. Great. This is probably volume here. Does it say? Let's see. RCA Victor. This says A and C. A and C. Now, what would A and C stand for? I mean, it's obviously got broadcast band and shortwave band. Why would they put A and C there? Why not A and B? Like, what happened to B? So if you look at this too, you can see a fair bit of wear around here. That's a great thing. What that says is this radio has been used a lot, and that it's finger wear from people's fingers being on the knob. So this radio was used a lot, no doubt about it. Not tuned so much, but somebody kept turning the volume up and down. Or turning it on and off, I guess, is also the deal there. So it has this interesting corner piece here. It's probably got cardboard in the back holding it in place, and you can see it's punched in here, and that's probably occurred from somebody picking up the radio. That's probably what's happened. So these guys, unfortunately, your fingers can get in them pretty good. Hey, here's a note. Power, oh, please don't tape this on the radio. No tape on a radio. Never, 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 never tape on a radio. Even this stuff. Now this coating didn't come off, but a lot of radios you pull the tape off, and of course the coating's going to come right off with it. It's going to ruin it. Power's on, new cord, gets stations, quiet, clean pots. Those are my instructions there. Power's on. Really? Look at this cord here. Somebody plugged this in? Look at this cord. Look at it, how cracked it is. Somebody plugged this in? Come on, really? Look at here. It's shorted here. No, really? Power's on. Well, I wouldn't recommend that, that's for sure. Now, here's something interesting. There's a phono input here, and there's a switch here with no label on it. This must be the antenna connections here, of course. So I can see up into the mechanism up here already, and I can see some what look like springs, spring bands are out of place. That's what it looks like already. Big transformer. This is the this model number is called A-1. Really? A-1? And this must be an outlet for driving your record player. There's a phono input here. And this may be a switch. You know, make phono and radio. Maybe that's what this might be. Looks like there was once a back on here. I mean, sure there was a back on here. It's long gone, which is very, very common in these older radios. The backs take off. Sometimes the back of the radio has an antenna on it, a loop antenna. It's very important for that radio. Without the back, the radio's kind of, well, it's diminished quite a bit. Not this one. This one just has antenna terminals here. Again, there's no label. Well, there is a label. Antenna and ground. I was about to say without the back, the labels are gone, but it's actually labeled right here. Ground probably means a direct connection to the chassis here. Well, we can't do anything much more with this radio without changing this cord, so I think the cabinet's got to come out. See, there's an asbestos sheet down here. You can see little bits of it. It's been roughed up a little bit. I'll do my best just to leave that just as it is. Knobs have to come off here. These guys, well, we don't know. Ooh, boy. There we go. 4 knobs off. Very good. Okay, and transformers on this side, so we'll set it with the transformer down. 3 big screws. So somebody put some tape over these because the screw heads are actually protruding slightly. There's 1 foot here, no feet anywhere else, so it needs some feet, or it's going to scratch everything up. So I'll do these lower screws, leave it hanging from this upper screw for now. I'll just loosen it a little bit. I hang this over the edge of my bench here. Okay, 3 bolts out. Now, is it ready to come out? Sometimes the front rises up very high in these radios, and then there can be stuff up here occasionally, like there's a nail sticking out right here, just a little bit. Wonder what that was for. And so as you draw the radio out, because of the angles, you can't see what's happening up here. You can get the top caught on something under here, and you know, radio's heavy, and you can do some damage before you know it. I don't think that's the case here. Let's see what's going to happen to those buttons. They're going to come out. Oh wow! So the whole sheet of asbestos lifted here. You might be concerned, asbestos, oh my gosh, isn't that going to give you cancer? Well, if you took this asbestos sheet, did this with it, rolled it up in a ball, came down every morning and took a good deep breath of it, maybe you'd be making yourself maybe you'd be taking a risk. You know, we can just cut this thing right off here. And I'm not any kind of expert in that, but I think realistically we're contaminated by many things. Asbestos is just one of them. So this really didn't come out at all. Let's try it again. Oh, yep, it's coming out. So it's ruining. The asbestos sheet is getting all knurled up under here. I don't want this to happen. It's gonna come out. Let it come out. Oh man, so this is kind of like the worst case here. So I'm not happy about the situation at all. It would have felt better if I had done this out in my garage. Okay, we're out. It's coming out. Okay. Whew. Okay, so I'm going to take this out in my garage. I'm going to remove the asbestos sheet from it out there, and the way you dispose of these, I'm going to dispose of this. Here, the rules are this amount of asbestos. You put it in a plastic bag, put another plastic bag, like put it in 2 plastic bags, and then you can throw it out in the regular garbage. This is not like an industrial level waste here. It's nothing like that. Okay, so I got little asbestos fibers on my finger. I've got fibers on my fingers. Okay, and I am trying now to shut down my computer. I'm having some trouble. See, live. Okay, back from the garage. Asbestos gone for the most part, but not all of it. There's lots of little bits and pieces of it stuck here. In fact, this was quite hard to get off. I was surprised. I really had to pull on it to get it off. And I just brought it back in here. And I see there's a fair bit of this. So you get the fibers wet and they won't fly around. And you can start getting them off. Asbestos. I wonder how many lives have been saved by asbestos. Now that would be hard to calculate. I guess if you're in the insurance agency or insurance industry, you might know how to calculate something like that. But the purpose of asbestos, for the most part, was to prevent fire from expanding or traveling or whatever. It had to do with fire protection. And with it, I'm sure a lot of lives were saved. We used to go to a cottage that we rented, and it had this would be very common, it had a wood-burning stove in it, and behind the wood-burning stove on the wall was a large sheet of asbestos, a great big sheet of it. So this isn't coming off very good. Here's a chunk of it here. But I think I've probably got any loose fibers taken care of here. We can carry on. Nothing like a little rock fiber in your lungs in the morning. Okay, there we go. Hang on to this for now. I'm just going to bear with me. Whoops, a second here. Just want to rinse my hands quickly. Okay, let's look at this guy and see what we got here. I'm sure I'm the first person to go in the back. Well, a lot of these radios actually had a repair or two earlier in their life. Often a tube replacement, I'm sure, is what it would amount to. But in some cases, the odd capacitor gets changed somewhere earlier on in its life. So looking at this one, what do we see? So we see these black molded capacitors in here. These guys tend to crack. The shell tends to crack on them. Not terribly reliable. We have these wax ones here. 1, 2, big one there. 3, 4. Not many of them, just a few. They're not reliable. There's one back in here. At this point, after this many years, almost all these wax capacitors are shot. Very, very seldom have I come across a radio where I could just walk away from them. Actually, I have one that appears to work just fine with all of its original wax capacitors. And appears might be the right word there. The wiring is it's not as stiff as I expected. Ooh, that's pretty stiff. So a lot of these radios, you do not want to really bend the wire, like this one here. This yellow colored wire, the coating on it, just looking at it, I can tell if I just push on this, it's just going to shatter. Same thing with this wire and this one. So you want to try to do your work on it without moving any of those wires, because as soon as you start moving them, you're going to have to replace it. And if you go to replace one wire, you'll probably end up moving others, cracking them, and the whole thing gets out of control. So in my own personal view, the less done the better. And there's an example of where less can be done if you're careful. If you're not careful, you get into a jackpot, which is a place you do not want to be. This looks like a big wire wound resistor here. It's kind of out in the open, a little bit in the open here, I guess, so it can be hot and not heat other things up. So an interesting question is, do we dare turn this thing on, like put a new cord on it and power it up to see what happens? Well, I think yes. Yeah. Why not? As long as we do it carefully, it's really not a problem. Probably this outlet is fed directly from here. I can see the wires, in fact, right from this cord right to the back here. This is a perfect spot to attach a new cable. Pull this guy out of here. Yeah, very good. Try to cut away the. Maybe I'm going to leave a little. I'm going to leave a tail there for now. When I go to solder the new one in, I can pull on the tail, pull the rest. When I've got this melted, I can pull the wire off. Maybe get it out of the way. So these two wires, they go here, they go here. So this is 120 volts with a switch going to the primary of the transformer. And these wires, as always, are very stiff. These ones aren't. These are probably the heater leads. Powering the heaters, although these green ones might be the heater leads. I don't know. So I'm checking the wire stiffness so I'm aware of what I'm up against here. So again, the cloth covered wires tend to be a little more flexible than just these early plastic covered wires. Especially, in my experience, the green ones are particularly bad. Sometimes you can open up a radio and look in, and the green wires have already lost their insulation. Here's two green wires up here that are right in contact like this. I'm not going to touch them, but if I were to, there's a chance the insulation would break on both of them and they'd short out. And that would be kind of hidden from view even. So, well, lots here to go wrong accidentally with these stiff wires. The antenna connection runs straight up to this antenna coil, which is located on top of the radio to keep it out of the inside of the radio. And the other lead, the one marked ground, comes to here, and then comes to here. I don't see it actually. Well, it also goes another wire going down here. I'm looking for the connection to the chassis. Well, I don't see one, and I don't see a wire running from here either. Of course, I don't see that much because it's a little dark. Let's put some light on it. Okay, so we'll take another angle. How is the chassis involved with this radio? Now, it's got a big transformer. This isn't a 5-tube radio. They're not in series. So the chassis could be done this way or that. I see a big blast of solder here. And they're soldering the socket base for this tube to the chassis. Same thing here, every one of them. So we know that's connected to the chassis. Now I'm looking for anything else that might connect directly to the chassis. Like for instance this input. The outside part is, I'm sure it's touching the chassis. There's only one wire coming from the center post here, so where would the other wire be? It has to be the chassis. This is the A and C switch. This looks like a tone switch. This isn't the AC switch. This is the A and the C switch up here. This is a band switch here. This must be tone, high and low. I see when you flip it this way, you've connected to a capacitor that's hidden back here. And the capacitor is going to ground through this connection, I guess. There's no other wire, so it must be again connecting to the chassis. That's probably the tone control, high and low. I don't see anything else connected to the chassis offhand. Here's the filter capacitor here for the power supply. This big guy, metal in a metal can. It's a good chance he's shot, but maybe not. Maybe not. So I can see two terminals here. So there's no insulating plate here. And there's at least two, so I can't quite see, at least two capacitors in this. 70 at 450, 10 at, well, it looks like 450. And I only see two terminals. One of them has a bare wire running from it. Bare wires like this often indicate ground connections. That's not a ground connection. Like here's a bare wire running all the way through here. But I don't think any of these are ground connections at all, or grounded connections, chassis connections. Okay, well, I don't see anything in here at all that makes me say, wow, this would be crazy to try to power up. Foolish? Maybe. Crazy? No. So I'm going to take a little break. I'm going to put another cord on here. And we're going to, as long as they don't fall down here, we're going to power them up and see what happens. Okay, just removing the original wires here. It's a lot to heat up. There we go. Okay, the new cord. Here it is. I can either tin these or not. Not sure. I'm helping myself by tinning them. I think I kind of want this to come up underneath. The thing about working with stranded wire is strands can go off on their own and end up, places you don't want them, and you might not see them. That's the problem with it. Like this. Plus, copper's not the friendliest metal to bend. Get on there. Okay. I need the, on. Now it'd be pretty easy to get solder to flow on the wire, but actually not make it onto the connection underneath. I want to make sure I get enough heat in here to do it. Yeah. Okay, now the second one's going to be more difficult. Wants to do is move away from where I want it to be. Yikes. Okay, let's try soldering that. Same problem again. Easy to get the solder on the copper wire you just put in, but getting it to go right into the connection. Yeah, that's good. Yep, good show. Okay, we got a power cable on here. Now we're really heading for trouble. So I am going to power this up, but I'm not just plugging it into an outlet and letting it rip. I have a couple ways to control the power. This guy's heading for the garbage here. I have a very simple kind of a home-built approach to controlling power on the startup of something like this, and then I have a professional quality machine designed for this exact purpose. I also have an isolation transformer feeding the whole show. So here's the voltage control box here, and up above it you see a couple of light bulbs. Those light bulbs are what are called dim bulbs, or dim bulb system, if you like. What's this? So I can send the power here through these light bulbs. These are old incandescent light bulbs, and if there's a short circuit here, all it does is turn those lights on full blast, and will prevent something from happening here in the radio, or at least slow it down, or me popping my house circuit breaker, or depending upon a big circuit breaker to save the day. Before I do this, let's just take a look at something here that I noticed. What is going on here? So these are the things that are actuated when you push the button at the front here. What's this deal? Look like spring metal, but there's one on each one, and they're all broken. Every one of these is broken. Over here, no, see, on this side they're not broken. What are these? What's the idea there? Oh, look at that. Let me push this one. So this one, you know, something's pulling it back. I actually don't see what's pulling it back. This one too. What would that paper be there for? These are all popping back. No, they don't seem to be doing anything, except maybe this whole mechanism is discombobulated. What it should be doing, you push the button part way, it then engages mechanically with the tuning capacitor and rotates it to a fixed position, the position that you've adjusted this for. Yeah, something completely wrong here, I think. You know, I know what it is now. Okay, I know what they're trying to do here. That's no wonder this thing didn't last forever. So you have this material here. It looks like paper, but it's probably more like a cloth or something with some strength to it. And you see how there's a lower piece to it and an upper piece. So it's actually like this. And then when you push the button, this thing will rotate the shaft to a certain position. These pieces of paper are responsible for tugging on the shaft and causing it to rotate. So these are gone. This is history. These ones not gone, but you know, if you tried to make it work properly, I think they would be gone. And these knobs rotate, which is probably the adjustment for. Oh, it feels more like it's unlock and lock. Well, it could be like, you know, there's a lot of cars that have self-adjusting buttons, which I always kind of wondered about, where in a car, you pull the button out, oddly enough, and then you push it back in, and that would memorize the location of the tuning capacitor onto the button through a mechanism of this sort. So these ones you would loosen. You don't pull them out, you loosen, tune the radio where you want it, probably push the button, and then lock it, something like that, and then that button is tuned to there. There's some words written on the side of the capacitor here. United States of America. Well, seldom do you see the whole thing written out like that. United States of America. Somebody's written something in here. 6SQ7, they've written the type of tube here. Speaker's in good shape. A lot of dirt. We got a light bulb. A light bulb is useful in doing radio repairs because it reminds you that the power's on, but I'll bet you this bulb is shot. Let's check it and find out. Okay, check my meter. Yep, check the light. Hey, it's good. Doesn't look good. Okay, we'll put it back in. Maybe we'll put a new one in later. Okay, we're ready. We're ready. So at this point, what I need to do is go and have a little break, drink some coffee, get ready for the excitement of turning this on. Who knows what'll happen? Okay, put your money down. Actually, we got a wager here. So here's my wager. Okay, I got an American penny. I've got a Canadian dime, queen on the back, and I've got this coin. Which where's this from? This looks like this is from Japan. I don't know. It's got Japanese or Chinese or maybe even Korean. Tunhang. I don't know. I don't know where this one's from. So I don't know what this is worth, so we'll pretend this is worth $100. Okay, $100 on the line. $100 says I'll plug this in and it'll work. Yeah. We'll find out. Oh, don't you know, I got a phone call. Yeah. Okay, well that was typical of some of the calls I get. Some gentleman from Toronto. Hello, do you do wire repairs? Oh, it's a wire repair, like headphone wires? Goes, no, I work in a nail salon and I have this special device I use. Sorry, if it doesn't have vacuum tubes in it, I probably can't help you. So, anyway, I get a lot of calls with people asking me to solder wires. I'm kind of stunned by that, but get your own soldering iron. Okay, we're ready now. So, a little practice. On, off, and volume, tone, I think, high and low, band, shortwave and broadcast, I'm guessing. And tuning, of course. Here. So I've cleaned this up a little bit, especially the tubes here. I couldn't stand looking at those dirty tubes. Whoa. And I suppose it helps them cool off a little bit. If they're covered in dirt, they can't maybe radiate the heat out as much as they could if it's just glass. I'm not sure of that, but I'll bet you that's the case. Okay, so I'm going to turn on the power here. Now, if you look up, you see my hand reaching for the switch here. If I knock that switch down, power comes here through those lights, shows up on this little box, and we can read the voltage. And I'm also mentioned this. I'm doing this with an isolation transformer. This guy is an isolation transformer, but I have another one behind that for reasons that are irrational. Switch is off, power's on. Nothing should happen. Nothing has happened. Check what voltage we're aiming for. 108 volts with full power. But actually, it's coming through the lights, but it doesn't really matter. That would be without the lights. It's the same. 109. Figure that out. I guess this thing draws a tiny amount of power itself. So I'm going to cut the power off, and I'm going to turn the power on, and I'm going to hit the power switch. So what should happen now? Hit the switch. These lights should come on fairly bright, and then dull down fairly quickly. And what's happening is the heaters in the tubes are heating up and drawing less power. Once they get hot, you see the light come down. It may go right out. You can't even see the light over here. It may not. And then as the tubes heaters heat up fully and they heat the cathodes and the tubes begin to conduct, more current will be drawn by the radio and the lights will go up in brightness about like that. About like that. Okay. Now, other things could happen. The thing can be a screaming hummer. You know what? That's not the case, because didn't I see a note? What did I do with that note? That I peeled off, and it said radio works, just weak. Yeah, I should improve my bet. I don't have any more money. I can't improve my bet. Shoot. I was going to really clean up on this one. Okay, so switch is on, volume is up just a wee bit. Here we go. Through the lights. So things happen very fast there. 84. Radios usually work around 90 volts. They start working, but different radios, different tubes. I am looking at the tubes. The glass ones are all. Wait a minute. She did say it worked a bit. I had an antenna connected. That's full tilt. It does work a bit. She said very quiet. Totally distorted. This is Buffalo. Buffalo on 84 volts. Okay, so I'm going to raise the voltage up. I'm not going to put it full. I'm just going to raise it with this control here. Get it more up, like in. Let's get it higher yet. That's not even 90 volts yet. So, okay, so what we're going to do, I'm going to turn this down. I'm going to flip it like that. So now, whatever I adjust this to is the voltage that will be on. It's 87, 95, just under 100, 102. Let's leave it there. Volume. 30 volume control. Very dirty volume control. Okay, any other observations we can make at this point? Output volume level. Well, the wonky volume control, but it doesn't seem to be very high. So the radio seems to be fading out as we're fooling around here.
Represent one thing, and it will be generalities because I'm sure again it comes down to agent and personality type and deal with the hate.
It's very broadband tuning.
Terrorists. Thanks for your time. Is it like difficult to deal with contracts like that where you're dealing with a player?
It's running one station into the next.
Who believes he's the guy. Well, Gus, I'm going to talk to a guy who's walking across northern Ontario to raise money for breast cancer. It's Breast Cancer Awareness Month, and we'll also be talking about Canada's limits on international students. He looked at the researcher, and
It's picking up pretty good. Now, I'm going to get a copyright hit on that. One thing to bear in mind, in my shop I used to use a terrible outdoor antenna. Now I have a very good outdoor antenna. And so radios perform well in here now when they're hooked up. This is the antenna lead here to this outdoor antenna. It's a mini whip antenna in case you're interested. And the results are great from it. I have a huge long lead in to get to my shop here, and yet there's enough signal to drive these radios well. But hook this up to a wire antenna, just a regular wire antenna, or 10 feet of wire on the floor in your house, and you might pick up nothing but noise. So bear that in mind. So this guy's working pretty good, but he's got problems. So the first problem is to clean up this volume control here, which is easy to do. I'm going to shut the power off. I see the speaker sticks out here, so if we tip it up on its side, it's going to be on the speaker. That's probably not really a problem. This way, we got the light in the way here, so flip it right over. It's going to be sitting on this tube and this piece with this. That's not so good either. So we'll flip it up on its side. I've already had it on its side once. Let me just, for safety's sake, even though the power's cut off, I like to pull the plug out. So you have a visible means of separation in the circuit. That's pretty stable. Hey, that means I won. Okay, pay up. Everybody pay up. I'll expect a check in the mail now. Power's on. Gets stations. Quiet, clean pots. That's exactly right. Very good. That's a student of mine, in a sense. So I want to clean the... So what I use, and this might upset some people, I use WD-40 to do this. Some people are really against it. So here's the volume control. You can see where the leads are going in, right on the top here. And they can't seal this up 100% where the leads go in. So that's a place where you can spray in the cleaner. And I'm going to... Should we do this with the set operating? Okay, I've just noticed now we have a wire here with the insulation coming off at this green wire. I think I was talking about this part of it. I didn't look down here. The insulation is broken off, and there is another component wire right beside it. It's just on the, don't move that, just on the verge of contacting each other, but not quite close. But that's what can happen in these radios, especially if you start monkeying around, which I am doing now. I don't think we need this on. I'm just going to spray a little bit in there. That's probably more than I bargained for. It's like the pressure's gone in my can here. So I like to have it on when I'm doing this, because then you can hear it get cleaned up. But I'm going to leave the radio up like this, and we're going to start it up again. Is there anything else that needed to be? There's no other controls like that. Although these can become very sticky in here. This one is not, but I'm going to help it with just a wee bit of WD-40 right here. Just a wee little bit. Oh, my stomach, holy smokes. My stomach tries to talk to me all the time in the morning. Very good. No string slippage at all. Okay, let's power it back up. We'll go again through the dim bulb. Approach. Just to be sure of things. It's no problem. Give it the full Monty. Let's see how much this helped. What happened? So we might be encountering now, because you get rid of one problem, you can clearly see the next problem. That's kind of what happens. It sounds different, doesn't it sound tinny compared to how it sounded? That's full volume. Okay, I think I'm going to leave it here. Let's turn it off. Let's make sure the switch really does work. This could be, the lack of volume can be everything from a bad tube, a weak tube, and almost any one of the tubes could be weak and cause low volume. And but it also could be bad capacitors and even resistors that are off. We don't know yet. So next step with this radio, easy step would be to test the vacuum tubes and get that out of the way early on, because it could be the output tube is weak. Then the next step is to check some voltages under the set and make sure, especially the grid voltage of the output tube. And from there, replace those few capacitors. And after that, go through, do an alignment. First, the IF alignment. Could do that almost any time, but rather do the part replacement first. Do the IF alignment, and then there's going to be a couple other alignment things. Too bad about the cool push buttons. They are not going to be. Well, there's one or two here that still seem to be. It's all broken on this side, but good on this side. I wonder what that means. There's somebody, I don't know, used it a lot on this side. I don't know. Oh well. Thanks a lot for watching, and we'll see you on the next video. Have a good day.